let's take a look on how we can set up narrowband for our fluid simulation here. Now, narrowband is a technique that was introduced in Houdini 16.5, and it essentially is a very useful thing to optimize our simulation times. Now, I have this research paper here, and you can find the link in the description of the video, or you can find the link. Actually, I have done a sticky note here with the link to this research paper. And what they talk about is essentially the narrowband, the fluid simulations with and without narrowband. Now, you can see on the left-hand side, it's only simulating a top layer of our fluid simulation, while on the right-hand side, you can see there's a lot more points throughout the fluid tank. Now, the results are almost identical in both the cases, but on the left, you can see that there is 1 million points as opposed to 24 million points on the right. So obviously, when you're simming less points, it's going to cut down your simulation times massively. So simulating 1 million points and simulating 24 million points will not have same simulation time. So one will have less and one will have more. Now, here's the thing, the emptiness that you see here, so this blue area. Now, when we set up narrowband inside Houdini, Houdini creates a surface field there in order to sort of replicate the behavior that you see on the right-hand side here. And we're going to talk about that just in a minute. So going back to Houdini, what I have to do is I'm just going to drop down another ocean source node to showcase the narrowband side of things a bit better. And I'm going to initialize into a flipped flat tank, size 10 by 10 in X and Z, height of the objects, and I'm going to visualize that tank. And you can see, okay, let's switch the boundary layer off. So now you can see that we have our fluid tank here, and it's filled from the very bottom of our tank to the origin, which is 0, which is our water level here, which is set to 0 by default. Now, if I click on or check on narrowband particles, you can see that a lot of particles below are culled, and that culling is controlled by the layer size here. So you can see if I put this to, let's say, 0.32, we barely have a sheet of water, while anything below that sheet is just empty. One thing to note though, when I switch on narrowband particles, you can see I have 250,000 points here at the bottom right of the viewport. Now when I switch on, not only I have less points, because obviously most of the points are culled, I also have 62,500 voxels. Now if I middle click onto my ocean source, you can see there is a surface field here that Houdini creates when I actually check on narrowband. If I check it off and I middle click on my ocean source node, you can see there is no surface field. So yes, it is creating a surface field, and any object, let's say there is an object falling into this sheet of water and it collides with this empty area where our surface field is, Houdini would automatically create points around it. So it's not going to be like, oh, it doesn't have depth, and as a result my simulation would look weird and bad. No, when an object will enter into your narrowband tank, it would create points around itself if it enters that empty area. So this is how this is the concept, this is the basic concept of narrowbanding our simulations, and it results in crazy low simulation times, which is great. You can be doing a massive sim without the narrowband, and you would need a massive render farm, 256 gigs of RAM to simulate God knows how many particles. But with narrowband, you can do the same thing with half the memory, if not less, 64 gig or even 32 gig in some cases. So, and obviously not to forget, the simulation times are crazy low relative to the non-narrowband simulations. Alright, so let's go ahead and set up our fluid tank and our flip object for narrowbanding. I'm just going to delete this, and in our ocean source node, I'm just going to enable narrowband particles. And obviously I'm going to put the particle separation to 0.5, so you can see the points are actually starting to appear. Now, one question, like, okay, you know, I'm gonna use the narrowband, but what is a good value of this layer size? How do I know what's a decent value here that I can put to have an effective simulation, a good looking simulation? Obviously, the obvious answer would be, like, you know, just try various settings and how it works. But fortunately, Houdini gives us a way to have a good starting point, and then we can change some stuff around that starting point. And that way is essentially copy your particle separation here. And what I'm going to do, I'm going to put this to manual so it doesn't calculate, and paste relative references right there. And then you multiply that value by the grid scale here. So copy parameter and paste relative references, and then multiply that value inside our .NET. In the flip solver there is a narrowband tab, so I'm just going to say enable particle narrowband, and then you copy that value and then you paste relative references. Okay, so it's multiplying 3 values, and at the minute it's giving us a value of 3. Now mind you, this grid scale and this particle separation, make sure that it's also paste relative reference here, so particle separation and grid scale. So I'm going to do the same thing with the grid scale, copy parameter and paste relative references. Right, so now let's take a look on how our narrowband tank looks like. Okay, so now we have almost 467,000 points and 1.7 million voxels in our surface field, which is great. Obviously, when we lower this setting down, the layer size is going to change. The lower this value gets, the lower the layer size will get, and thinner our sheet of water will get as well, which is great. So I'm going to put this back to 1 for now. And yeah, this is how you essentially set up your narrowband. Now, here's something that you should know. If I play this, it's gonna act weirdly, it's gonna start to sync, and that's because the surface field is not there, and it's just gonna act, it's just not gonna look right. It's not, because technically it's not right. Because if you remember in the flip object, when we were setting up our base fluid tank, we had set the input type here to particle field. Now we would set this to narrowband, and when we set this to narrowband, it requires a surface volume and an optional velocity volume. Now we do have points already with us, but we don't have surface. So how do we do that? Let's take a look into that. Okay, so obviously because narrowbanding, enabling narrowband creates the surface field, what we're going to do is we're going to put a BLOSUP down, right? And we're going to say particles, delete non-selected. So it's going to delete everything except our particles. So those would be our points here. And I'm going to put another BLOSUP down, and I'm going to say surface, delete non-selected. And this would be our surface field, right? So surface, particles. And in the .NET, in the flip object, under the subpart, I have my points, and in the surface, // out surface. Right, there you go. That's how you set up our narrowband. Now, let's take a look on how we can use VDBs to create collisions out of our cliff geometry and our ship geometry. And let's start doing some basic early tests for our simulations.